Okay, so let's start with our auxiliary equation, which is m squared plus 4, which is going to give me m equals plus or minus 2 I, which tells me that my complementary form is going to look like C1 cosine 2x plus C2 sine 2x. Okay, so then let's focus on this 4 cosine x plus 3 sine x minus 8, and let's look over our quick patterns real quick. So what would be the annihilator function for something like this? So the general format is d squared minus 2 alpha d, sorry about that, plus alpha squared plus beta squared, all to the n power, and we just need to figure out alpha and beta in this case. So alpha is the exponent of the e function, which there is no e function, so in this case alpha is 0. And beta is the coefficient of the argument of this trig function, so looking inside sine and cosine, it's 1x, so beta would be 1. So if I fill that in, that should give me d squared plus 1. Okay, and that piece, that annihilator piece, is going to take care of the 4 cosine x and the 3 sine x. The minus 8, that's that constant piece. So, what differential operator would annihilate out a constant, and that's just a simple d. Okay, so let's put all of that together. So that says that the d from the constant and the d squared plus 1 from the cosine and sine functions, and then d squared plus 4 was from our complementary solution, all of which should equal 0. Okay, so that says m squared plus 1 and then m squared plus 4. So we got m equals 0, plus or minus I, and then plus or minus 2i. Okay, now we already took care of the plus or minus 2i with our complementary, so that means our particular solution, let's see, from the 0, that's going to give us a constant, and then from the plus or minus i's, that means we've got some form of, let's see, so it's going to look like C, and why not, we'll call them, I don't want to switch, C1 cosine x plus C2 sine x plus C3 would be our particular, and I'm just going to make it easier for myself to call those A's, B's, and C's. Alright, and at this point we know the drill. I need the second derivative. So that's negative a cosine x plus, negative a sine x, plus b cosine x, and then the c disappears, and then the second derivative would be negative a cosine x minus b sine x. Alright, so let's evaluate that in double prime plus 4y. So that would be negative a cosine x minus b sine x plus 4 y, which was a cosine x plus b sine x plus c. All right, so let's do some gathering here. So that would say, let's see, 4a minus a is, so 3a cosine x plus 3b sine x plus 4c, and that has to equal the 4 cosine x plus 3 sine x minus 8. All right, so that says that 3a has to be 4, 3b has to be 3, and 4c has to be negative 8. So a would be 4/3, b would be 1, and c would be negative 2. And let's put that all together. So our general solution would be c1 cosine 2x plus c2 sine 2x, and then the three things we just found. So plus the 4/3 cosine x plus sine x minus 2. Hooray!